Alright guys, this is 4.4 part 2. We're going to finish up, try to finish up this section here with a second video. Let me give you some special logarithmic functions that you'll see most commonly. So we have the natural log, which is log base e of x, and we write this as ln of x. And then we have what's called the common log, which is log base 10 of x, which we just write as log of x. Alright, now recognize the inverse of the natural log is the natural exponential function that we worked with in 4.3. So to kind of give you an example of that, if I had the natural log of w equals z minus 1, well, I could also rewrite that as e to the z minus 1 equals w. Okay? Because these two things are inverses. Similarly, if I had log of 3 minus x equals 5, well, the inverse of log base 10 we would just write as 10 to the 5th equals 3 minus x. Alright, and then kind of going the opposite direction, if you had 10 to the 3x equals t, well, certainly we could rewrite that as log t equals 3x. Alright, so these are the most common ones you'll see. You can see other bases here, but they call it the common log because it's the most common one you see. Alright, properties of logs. Let's see. The log base a of 1 always equals 0. It doesn't matter what your base is. Log base a of 1 always equals 0. Log base a of a always equals 1. And if we had log base a of a to the x, well, that always equals x. Okay, so these are just some properties that you may want to familiarize yourself with as you're going through these problems. Now, it should be obvious here, but we'll restate the fact that log functions are definitely one-to-one functions, right? In other words, if log base a of x1 equals log base a of x2, then the implication is that x1 must equal x2. Okay, so log functions are definitely one-to-one. This is a huge statement here for working with logs. So as an example, if I had log base 5 of 5 to the 3rd, well, we know that's just 3. We're going to run through some examples here. Log base 8 of 1, well, we just said over here, the log of anything to anything of 1 must equal 0. For example, if we had log base 2 of 32, well, we want to simplify these things as much as we can. So I can rewrite 32 as 2 to the 5th. So this is actually rewritten as log base 2 of 2 to the 5th. And now, without using our calculator, we know that equals 5, based on our rules. Let's see, if we had the natural log of negative 17, well, that is log base e of negative 17, but that does not exist because we know we have to have positive numbers there. And I know I'm moving quickly, but you can go back and watch this video a little bit slower. Log base 3 of 1 over 27. We can rewrite this again, similar to what we did here, in a form that gives us an easy solution. Log base 3 of 3 to the negative 3, and we know that equals negative 3. Let's see, what if we had e to the natural log of 7? Well, remember, these two things are inverses. So if you raise e to the natural log, they're just going to be cancel out, and we're going to get left with 7. Let me make some more room here. finish out these examples. Let's see, what if we had 12, log base 12 of t minus 4? Well, 12 to the log base 12 will cancel with itself, and you're left with t minus 4. That actually falls under one of the properties that I just erased. If we had something like e to the 4 plus the natural log of 9, well, we can use our exponent rules to kind of distribute this differently. So we have e to the 4th times e to the natural log of 9, but that can be simplified because, again, these cancels and you're left with 9 e to the 4th. Again, our directions here are just simplification. What if we had log base 7 of 0? Well, can't take the log of 0. It does not exist. And if I gave you something like this, k equals h minus c to the at. Well, we can rearrange this as k minus h divided by negative c equals negative t. Alright? This is a bunch of examples here on how to use those properties of logs that we gave at the beginning of the video to rearrange things to fit the format that we want. Alright, that's where we'll cut this section off. I may have a little bit more, but I'll give that to you in class. Alright?